Hello guys, this is Nick Z. I was just wanting to show a couple things here, mostly the ape core or apicore. I'm not sure how you pronounce it. In his video he's got it as ape core, but I guess it's apicore. Anyway, this is my setup as usual. That's the Mazzilli there. It's got the scope probe on to the cap, the WIMA cap there. And right now the device is off. This is my Kacher circuit as usual, nothing different about it. This is the kind of ferrite that I use. It's just some tape with ferrite pieces into it. So I stick that in the car. You can slide it around where you want. And the grenade, it's kind of falling apart on me on the end over here, but I'm probably going to change it, so I haven't even messed with it yet. It's still working. That's the core. Now this is a 24 volt core, and I'm only running it on 12 volts, so it's very, very inefficient at this point. But so what? These are the magnets that I use, and I'll show you what they do in a second here. I've shown it before, but just for quick reference. Now this here is this flyback, and this full bridge rectifier goes back to the Kacher. One second. The Kacher circuit, which is this one. Okay. And so that feedback loop goes right into the Kacher's input. But at this moment, right now, I don't have it connected because these bridge diodes aren't holding up. They can't hold the whatever it is, the frequency, the amps, whatever. They get hot. So anyway, let me turn this thing on and show you what it does on 12 volts. I'm going to turn off the light for a second. I really can't see what I'm doing either, but whatever. Okay, I just turned the induction circuit on, just the induction circuit, and this bulb is glowing here. This is a 100-watt bulb, but remember that this is just running on 12 volts. So with the magnet on the yoke, I can adjust it a little bit. You know, I can dim it or I can try to brighten it up, but basically that's kind of what it does to the 100-watt bulb. And okay, so now if I turn the Kacher on, this Kacher is also, right now it's running on a wall adapter. So let me turn the Kacher on. It's a wall adapter. I think it's like 18, 19 volts. So it's got a little bit more output than the 12 volt one that I'm running the induction circuit on. So here's the Kacher onto the 100-watt bulb. You can see the neon glowing here. If I turn this light on, it just drowns out everything, but that's kind of what's going on. You know, I'm trying to get that one little bulb there to light up, which is a 100-watt bulb, and just using this low power to see if I'll do it again here. This is the bulb here. If I turn the Kacher off, that's the difference right there. So it's not a, you know, it's not a great difference, but turning the Kacher on again, turning it off. Okay, but if I turn it off, right, and I turn on a couple of other bulbs here. I think they're 25 watt bulb. I have to retune for them because they're really, can't even see them. I can see them, but there they go. Okay, so I retuned for these two bulbs, right? So that's what I'm doing here with the ferrite into the grenade, and then now with the magnet on the yoke core. Okay, so these are two 25 watt bulbs or something like that. They're not going that well. But now I'll turn off the Kacher, and we'll see if there's any difference. Oh, sorry, I'm turning on the Kacher. You can see the neon glowing. You can see when it's off. I'll get back a little further. You can see when it's on because the neon will come on below, and then the other two bulbs are the incandescent bulbs. So there's with a Kacher on, that's with a Kacher off, Kacher on. You know, it's not outrageous, but I'm using very little power. And the reason I'm doing that is because I don't have my Zehners on the induction circuit, so I can't run it up above 12 volts for now. So anyway, it should be the same thing, but much more pronounced. Doing the same thing, running everything on 24 volts, or running the Kacher on the induction circuit's output, which even at 12 volts, if I connect the Kacher's input to the yoke secondary coil's output, I get about 20 volts or something like that, somewhere in there. It'd be nice to get 30 or whatever, but that's what I get right now with the 12 volts. Now if I connect the 24 volts to the induction circuit, I don't know what'll happen. I may get 50 volts, I don't know. Haven't gone there yet. Anyway, that's the wave there. I want to show you on the scope just what it does when I remove the magnet from the yoke core. Here it goes. Did you see that? Lights go out. Put it back on. Lights come back. See that? Okay, I can tune it a little bit. One way or another, get it to where it shines best. And I can tune it again with the ferrite in the core. And so that's what it looks like. Again, Kacher asked me if the magnets increase the output, so just watch it as I remove the magnet from the core. There you go. So anyway, that's what I wanted to show you. No big deal. I'm still working on this, but I do seem to be getting, with this setup here, I'm still running the three-turn capacitor coil inductor setup apart from the output coil on the grenade. The output coil is connected just to the bulb, just to those bulbs there. This is a 100 watt bulb, and this is a 25, and this is a 25. It's hard to tell anymore because the numbers are gone on the bulb, so I've been screwing around with them too much, I guess. But anyway, that's the setup, and I'm just waiting for my Zehners, and then I'll connect up this device here and get it going. It's working. It's just that it overheats the diode. So once I get the diodes, I can run it through that route and run the Kacher off the yoke secondary through that rectifier. Anyway, that's all I wanted to show you for today. Hope you had an interesting little video here. I've got nothing special to show, but it's a step in the right direction, I feel. So anyway, thanks for watching.